What's up, Cole?
Can you hear me?
Yeah, now I can.
Yes.
So I'm probably gonna. I don't know why my camera's not. Oh, actually, that's why. I'm gonna wait just a few more minutes. Everybody else joins. You're in software, right?
Yeah.
Yeah. What phase are you in?
I'm actually doing the pre-work right now.
Oh no. Okay.
Yeah. I start in June.
Word. Well, this is I'm in data science, and this is gonna be my presentation for my phase 2 project. So not quite in your like field of study or whatever, but I'm sure it'll still be. Hopefully, you can like ask some like hard questions for me.
Well, I really don't know much about data science, but I'll try.
Sure. Well, so that's why I wanted to do this, because with the project presentation, like the whole like scenario is that you're like a stakeholder and you're like a non-technical person, like that doesn't like code or anything. So I'm supposed to be able to like communicate this to somebody that like doesn't like actually know what like about this sort of thing. So that's why I wanted to like practice that like for real, you know what I mean? Because like your instructor that you present to, like they like actually do like know like what you're talking about. So yeah, I don't know, it seems like good practice. This is my buddy Cole, too. I know him from like university school.
Okay, cool.
He's
Hello.
in like finance and stuff. So the presentation is going to be about real estate, like the real estate market in Washington. So
Oh, I'm really into real estate.
yeah, okay, well this will be like this
Yeah.
is perfect then. Yeah, I'm trying to like stall just a couple more minutes in case anybody else joins it, because I kind of like put the word out, but it might just be the two of us. I don't know. So what made you want to oh yeah, there we go. Hey, Austin. What made you want to do Flatiron? Like what were you doing like before, and like what made you be like, oh, I gotta like learn code?
Well, I've always been interested in coding. I took, Visual Basic in high school and JavaScript in college, and built websites and stuff as a teenager, but never pursued it as a career. I'm very artistic. I was a musician for a long time, and I guess I still am, but professionally, and a writer, and just really creative. And I've always been afraid to go into mathy, computer sciencey things, because I just thought that's not my brain. But it's just a lie I've been telling myself. I can have any brain I want. So I decided I was so sick of telling myself no, just give it a shot, see what happens. So I started doing Code Academy and some other websites, and Free Coding Camp, I guess, and
Yeah, Free Code Camp.
yeah, and I was really getting into it, and I said, well, why don't I try something that's more legitimate and maybe going to give me better education. So I just like a month ago or so decided to apply for Flatiron.
But I think like one of the things that you really get from a boot camp that you don't necessarily get on like whatever is like this sort of thing where you meet like other people like entering the industry like kind of at the same time you are, and like the instructors you make connections with and all that. Like you don't get to know when you're like just like kind of typing away on like free code or whatever. But free code camp's really cool to me because my degree is in Spanish, and they have most of their curriculum available in like, multiple different languages. So like sometimes I'll go in there and I'll study like HTML like in Spanish just to keep like my Spanish sharp. So I really like free code camp for that reason. Well, it's 5 hours, so I guess we'll go ahead and start. And if anybody else joins in, we'll see what I have to share this.
En het wordt allemaal duurder in Nederland. Ja, we wouden dat we op een gegeven moment heel lastig sparen.
And hey, Kurt, would you mind muting your mic?
Oh, I'm so sorry. I thought I had it muted. I'm sorry.
Okay. Thank you. Okay. All right, well, good evening, everyone. My name is Zeth Abney, and this is my, let me get my timer started. My presentation for my market penetration analysis in King County, Washington for Flip House LLC, which is the figurative company that I'm doing this analysis for. You guys are in this situation, stakeholders, non-technical stakeholders. So at the end of this will be like a Q&A, and you'll get to ask me questions about the presentation, anything that I didn't cover that you want to know about. But try to ask questions like as if you're a stakeholder and I'm kind of giving you guidance on like what to do with your business. So anyway, what I did was I built a multiple regression model to predict housing prices based on a set of other pieces of information about a house, such as its square footage and that sort of thing. To build this model, tonight what I'm going to talk to you about first is sort of some of the business issues that I considered that Flip House LLC uniquely faces in terms of entering this like a new market. I'm going to talk a little bit about the data that I actually used to build the model, how I manipulated that data to build like the model itself. And then at the end, we'll get to like the really important stuff. And we'll talk about what my interpretation of the model is and what kind of real action we can take based off of the information from the model. And then we'll have a little Q&A there at the end. So what are some of the business issues considered? Well, we're penetrating a new market, so we need to understand both the opportunity cost of not investing in potential real estate opportunity or piece of real estate that's on the market. We also need to understand, of course, what are the potential returns on it? If it's within an acceptable range of our opportunity costs, is there enough ROI to make it worth our time? And that sort of thing. As a house flipping company, of course, we work or operate on both sides of the transaction. Sometimes we're buying houses and sometimes we're selling houses. So the three broad questions that I tried to answer with this model is when, where, and what to buy and or sell. So let's talk a little bit about the data that was actually used. We're entering a new market, right? So we don't have any historical data on how our business operates and its successes or failures in this market. So I used some data that was publicly available from King County, Washington themselves. By the time the mall development was all said and done, I ended up using about 93% of the original data available. It's also important to note that the data only covers a time span of about 1 year from May to May. So just keep that in mind as we go through this. A little bit about the actual process of model development. Like I said, we ended up only using about 93% of the data. That's because some of the stuff was thrown out as outlier data points and other things of that nature. We had to encode some of the data. So to plug in the data into this statistical model that I used, everything has to be a number. So if we have a column where there's like good, great, and excellent, like words, then we swap those out for like say 1, 2, and 3. And so that way we're able to keep sort of the same information, but still represent it as a number so that we can use it in the algorithm used to build the model. After we sort of get done with manipulating the data, we move into rigorous feature selection, where we essentially build a model and look at how it performs using some model diagnostics. And we pick and choose which columns, if you imagine like an Excel spreadsheet and a table, we pick and choose which columns to include or exclude, depending on how they affect the performance and the reliability of the model. So once we get a model that we're pretty happy with, or just periodically throughout the process, we'll also go through model validation, which is basically where we'll take all the data and we'll split it into like say 10 different samples. We'll train a model with 9 of those samples, and then we'll test the output of those 9 samples against the output of the 1 sample left over. And we do that in multiple sort of like groupings. And that helps us sort of ensure that the model not only represents what's going on in the data that was plugged into the model, but it represents what's kind of really going on in the real world where the data came from. So let's get into the model itself. So I keep talking about this model thing, right? And that's basically what you see here in front of you, with the exception of a few other metrics. But this is basically what I'm talking about. And I don't want you to worry too much about all these numbers over here on the right. That's a lot to look at. Really just kind of zero in on these bolded words right here in the center of the screen. So you can imagine if all our data is in a table in an Excel spreadsheet, these bolded words are the labels for each one of the columns, right? So like I said, when I was building this model, I was trying to answer where, what, and when. So I grouped all of these features together, these bolded words, that's what we call our features, in a way that we can kind of inform ourselves as to what some real world questions that the model can answer. So I made this visualization here, and what I basically want you to get out of this is just a sense of how much each one of these questions sort of contributes to the model's prediction of the price. Or in other words, if you're considering buying or selling a home, like to what degree each one of these things might affect the potential price of that transaction, right? So obviously how far north the house is, the latitude specifically is the feature from the data. That mattered a lot, nearly half as much as everything else combined, of course. And as you can see, the fact that it's on a waterfront all matters quite a bit, and not to mention which waterfront it's on. I do want to point out though, that which waterfront matters in the sense that some of them drive the price up and some of them drive the price down. How much repair the home needs and so on. One more thing I want to point out here with this visualization is you can see that wind is almost not visible. So the model as it exists now is probably, I don't feel comfortable making any statements that I can empirically support with the model in terms of when to buy or sell. So unfortunately, at this point with the model we have now, we can't predict really anything about when to buy or sell a house, but we do have some good information about where and what at least. So in conclusion, what are my personal suggestions about entering this new market? You want something north of downtown, at least. Best case scenario, you get a waterfront property on Lake Union. If you can't do that, try and get something at least downtown or north of it, and autumn waterfront if you can. Of course, you want a nice view. Everybody likes a nice view. And naturally, if you're on a waterfront, you would like to have a view of the waterfront that you're on so you can show your guests and that sort of thing. Interesting thing, you probably want, as a house flipping company, if you're buying a house with the intention of fixing it and selling it later, you want to find something that's in need of actual repair. And I don't mean like just updated, like you're going to replace the curtains and put some new appliances in. You want something that's in need of like actual repair, because those are probably the only properties that you're going to find in a neighborhood that's nice enough that you would want to sell in it, but that you're going to be able to buy it for a cheap enough price that you can make a good enough profit off of it. Also, the model recommends adding bathrooms, to put it simply. There's a correlation between bathrooms and the price of a home. Of course, the more bathrooms, the larger the home probably is. And so that drives the price up. But as somebody who's lived on a lake for a significant portion of my life, as a lake person, if you will, in terms of bathrooms, what would be more interesting to me in terms of buying a home is like a 2-bedroom with an outdoor shower stall between the waterfront access and the home itself, than something without that and having like 3 bathrooms in the house. Reason being, anybody that's ever lived on a lake knows that you need some sort of like wash station, at least for your feet, anytime you go from the lake to indoors. You don't want to bring all that lake stuff inside. So the model recommends adding bathrooms. I personally recommend adding an outdoor shower stall or wash station like that, because as the rest of the model suggests, you want something that's on a waterfront anyway. So that is it for my presentation. If you want any more information or you want to read the detailed report on the analysis, you can find all that at the GitHub repository, which I can make available to you. And if you want to contact me in the future with any questions, you can contact me here at this Gmail. And with that, I would love to answer any questions that you might have.
Okay, do you have any data on what the highest return on investment is? What am I trying to say? Which properties have the highest return on investment? Would it be buildings with significant repair on a certain lake, a certain waterfront, or properties that are most need the least amount of repairs, but they're far north? Is there some combination of factors that display a highest return on investment?
Yeah, so I mean, I would get something that's in need of repair that's on a waterfront, especially like on Lake Union specifically. So that's the thing. You can find a lot of houses that that are in need of repair, right? The hard part's going to be finding a house that's in need of repair that is in a neighborhood where you're going to be able to sell it for anything that's worth buying it for in the first place.
Were there any other data sets that you analyzed that aren't included in your in this presentation, such as maybe
Yeah.
lot size or other
Um,
attributes?
Well, sorry, repeat your question.
Are there other data points that you analyzed in your research that that also would have a significant impact on return on investment? So, for instance, properties with a larger lot size or smaller lot size, or I'm thinking of the ability to build an in-law apartment. These kinds of factors that you maybe analyzed and there wasn't enough data, or maybe there was some data but not strong enough to draw a conclusion. So maybe you didn't report on it.
Right. So interestingly enough, there was a feature for like just the square footage of the house. We had a feature for square footage of just everything above the basement. We had a feature for square footage of the lot. We had a lot of like square footage information like that. But the only one that like sort of survived the filter, if you will, is this square foot living 15 feature right here. And what that is the average square footage of living space for the 15 nearest houses. But that's the only feature that we have that points towards like square footage of the house specifically. You can infer if like that, like with bathrooms, like the more bathrooms there are, obviously there's gonna be more square footage. But so these coefficient column, this first column you see to the right here, that's like the percentage that the price of the house increases for every unit increase in whatever the corresponding like feature is, right? So I didn't include square foot living in this visualization right here, because as you can see, it's like what is that, millionths of a percent. So there's not like, like maybe like from that we can infer that the price increases, by a thousandth of a penny or something for every like extra square foot, but that's not really a big enough impact to drive decision making. So I didn't really include it in like my final recommendations here, like right at the end. But we do have data on it, and I maybe could go back and build a model if I just use like square footage data and just started with that, then I can maybe build something that specifically predicts like what square footage you want. I could build something like that potentially, but the way I built this, I just started with like all the data I had available, and I kind of plugged it into a filter, and I saw like what was left on the other side of the filter. So yeah, does that answer your question?
Yeah, definitely. Thank you.
Cool. I also like looked at bringing in a completely other data set that I got from data.world. And if you look in the Jupyter notebook, you can see the code where like I imported the data and like manipulated it and tried to join it and everything. And so what I did was I got like the income tax revenue and the average income per capita or per household for each zip code, like in the data set. And I tried to look at if that was, I figured like that would be a strong predictor, right? What's basically like, what's the like tax bracket of your zip code? That's what I like kind of encoded it as. And that didn't even like survive the filter, but I tried bringing in like other data sets like that weren't even part of this like original data set provided by Flatiron. But it didn't survive the filter, unsurprisingly. Austin, Cole, y'all got any questions?
I don't have any questions. I followed pretty much all of that.
Okay. Cole, what about you?
What makes a property on a waterfront possibly be less valuable rather than, you said if a property is on a waterfront, it could mean that it's more valuable or less valuable. What is a case scenario where a property would be less valuable on a waterfront?
Lake Washington. So you'll see right here, like kind of like a quarter from the bottom, there's this feature called waterfront, and that predicts about like 0.35% of the price. So that's just if it's on a waterfront or not. Like if a property is on a waterfront, then the price is automatically going to be like this much more. Let me get my thing. So if a property is on a waterfront at all, it's automatically going to be this much more than an equivalent house that's not on a waterfront, right? That's what that means. Versus like Lake Washington, for example, for any house that's on Lake Washington, it's going to be this much less, or this much percentage less than it would be an equivalent house that's not on Lake Washington. You're kind of blinking your eyes. I'm not sure if that answers your question.
That makes sense.
So if it's on a waterfront at all, like that's a plus. So even Lake Washington probably. But you could think of it like within the set of waterfronts, Lake Washington is maybe like the last waterfront that you would want to be at, if assuming that you're on a waterfront. So unless you guys got any other questions, that's pretty much it.
Well, that was a great presentation. Thank you for inviting me.
Yeah. Was that like, I'm worried that I tend to like ramble, I feel like, and does that like all the mathy and like weird like technical stuff, does it make sense to like somebody that doesn't do stats all day? You know what I mean?
As someone who doesn't use stats all day, I will say that I was unsure if on that chart, if that was a percentage point. So when you're saying like on Lake Washington -2, is that out of percent, or is that a 1/10 of a percent, or what is the scale of that?
That's percentage. So it's all
Okay.
like a third of percent, like that sort of thing.
Okay. Okay.
And that's because the target variable price was log transformed. If it wasn't log transformed, then it would have been like for every unit increase in the feature, it's a unit increase in the target. So it'd be like by the dollar instead of like 34 cents instead of 0.34% of the price. So when you're talking about homes that are worth like $2 or $3 million, like 0.34% of the price like might actually like be like something worth negotiating over. You know what I mean? Cool. Oh, I probably should have said this at the start, but I did record this like for my purposes because like I blog and YouTube and stuff. So I hope you guys don't mind me being on the internet somewhere on a Zoom call, YouTube video. Cool.